This is a presentation that some of you, a few of you actually, will have already seen most of before. But there's some new bits, and actually, if I get to the agenda, if I can only figure out what on earth I'm doing, there is actually a piece of good news that I think you might want to embrace at the end. At least some of you, of the more adventurous sort, might want to embrace it at the end. And actually, I think this bears repeating in my experience of working with customers over so many years. So the idea that work can come from outside and you don't necessarily know what it is, and you don't know where it came from, and you don't know that it's going to show up, that's quite a challenge for us performance people. And DDF is one of those things where that really is very much in the offing. So, how are we going to manage this thing, and how are we going to stop it from taking over the machine, are key questions. So this presentation has evolved over the years, really starting from that standpoint, but growing and growing with a lot of other bits and pieces which I think are of real value. And we've got quite a few examples here when we get to them. So the introduction, I'm going to try and keep as brief as possible because I want to get to pretty graphs. So 2020, it's a slightly different presentation from before with a couple of extra things, as I say. So you can see from the layout of the agenda, at least in screen space, the examples are really the bulk of this. So I'm going to do some of these things very briefly. They're in the handouts, obviously, so you can look at them in more detail at your leisure. So what is DDF? Well, it's one of the major ways of getting work into ZOS, specifically into DB2. Has been around a very long time. Functionally has been refined many times since, I think it was 2.3 that introduced DRDA. Clients from a number of broad categories, so JDBC, from ZOS, from OS 400, which I almost never see, frankly, and other stuff. Now, the 3-character acronyms aside each of these really enable you to see at a very high level what kind of DDF work this actually is. I'm going to use a term that some of you know, which is feral SQL. There's quite a high risk of feral SQL, meaning SQL that probably hasn't been through all the problem and change that you would expect it to go through. So why do we care about DDF? Well, I've kind of given the game away already, but many modern applications use DDF to get into DB2 as opposed to a local direct attach. If you're being charitable, you'd like them to perform well. Well, actually, you probably would. You'd like them not to take over your machine, and you would like the low value distributed work coming into DB2 not really to drive your MLC unnecessarily. Actually, you'd like to know what this stuff even is. It's the bane of our existence when work shows up and nobody tells you it showed up. And finally, you'd like to ensure that zip exploitation is as much as it could be, which sounds like a trite thing to say, but is that actually is one of the examples I'm going to give you is exactly in that category. Okay, so feral, I've used the term. So really, to my mind, there are two kinds of DDF application. There's production, which is stuff with a regular arrival pattern and shape. It's probably managed by some IT people somewhere. It's likely to be tunable. It's possibly been through a reasonable level of problem and change, as opposed to feral, which is stuff that could come from anywhere at any time, not necessarily managed at all, other than perhaps by the user. So an example of production would be something like SAP, which we will talk about later on. And WebSphere application server applications typically would be in the production category. Compare and contrast that with things which I also see, things like Excel, things like ZOS batch coming in with type 4 JDBC connections from somewhere. Those are much lumpier, much less controlled typically. So that's why I categorize feral versus production. Now, it's important to know which of those you've got, because you might be applying different management approaches to production DDF versus feral DDF. And actually, in many shops, there's both. We spot stuff that looks very production-like, and we spot stuff that frankly doesn't look production-like at all. So that's a concept I'd like to introduce. Now, a couple of days ago when I did the So You Don't Think You're an Architect presentation, I put up this slide, and it's a useful one. You can do work on DDF at all levels, from the sysplex, well, really from the zip pool on downwards. We're probably going to spend most of the time on the right-hand side of this, although we will spend some time looking at SMF30, believe it or not, to do with DDF, and a tiny bit from RMF. So if we start at the top, and I won't spend much time on this because we've seen it before, obviously you can work out the zip usage at the pool level, and you can stack up the LPARs. I think that's known and understood, and probably in everybody's production kit bag by now. If you drill down, though, into things more directly DDF, then the service class is a good place to start. So this is a service class called DDF High, taking it across the day. And I'm going to try and explain this graph because I think it's more useful than just for DDF. So the black line is the transaction rate going through this WLM service class. By the way, notice the lowercase comment in the top of the slide, which basically is the description for the service class exactly as it was typed, which is something I forewarned you about whenever it was, Tuesday, I guess it was, maybe it was Tuesday, I don't know. Now, more to the point, this service class has a goal of 85% in 150 milliseconds importance 3. The green line is at 85%. And what we do with the numbers in SF72 subtype 3 is work out in buckets how many transactions ended in 50% of the goal time, 60, 70, probably 80, 90, don't quote me, 100, 110, 120, and then the buckets get a bit bigger, right? So what I like to do is to sum up the transactions as a percentage that end in any given bucket. And you'd be amazed the number of times everything ends in the first bucket, or nothing ends in any bucket other than the top bucket. I see that a lot in customers, particularly this year for some reason. So the blue series are representing transactions that ended within the goal time. The red ones are the ones that didn't end in the goal time. So if the red pushes down the blue to below the green line, very simplistically put here, you miss goal. So this is actually a service class where we're making the goal just at the higher volume times, apart from overnight when we easily make the goal. So this is obviously a tale of a daytime and a nighttime. And I suspect there's something quasi-batch going on very early in the morning with a different behavior from the online DDF. So this is quite a nice example of how you can use the 72 subtype 3 data to understand what the impact is on goal attainment for DDF as the workload builds up, let's say in the day. And here, clearly, the workload slows down as the transaction rate builds up, but not to the point quite of missing the goal. So that's quite a nice graph that if you can make one of those for DDF work, actually you could do it for kicks, you could do it for IMS transactions or TSO if you really must. Okay. Again, at the service class level from RMF, you can see how much of the CPU is general purpose engine never eligible for zip, how much is actually zip eligible and running on a zip, and how much is zip eligible but running on a GCP. And you would hope it was around 60%, and usually it is, but watch this space because sometimes it isn't. Okay, so what is a DDF transaction? Because I've a few slides back, I talked about transactions meeting goals or not. Well, a transaction is actually a commit stroke abort. So DDF, DB2 recognizes that as a transaction, WLM recognizes that as a transaction, and so does RMF. However, that's not a piece of work as humans would recognize it, or maybe middle tier applications would recognize it, because they would they and we would tend to recognize conversations, whole conversations between requesters and DB2. Now, some of those really are very few commits in scope, and some of those are actually rather a lot of commits in scope. So, you know, a quasi-batch DDF piece of work would be many commits, typically. It should be, if it's batch, it should be many commits. It shouldn't just be one huge commit. So really you have to think about transaction as a DB2 commit, however meaningful that is to you if you're not a DB2 person. The next point, I think, is that an SMF 101 record, and we are going to get low down and dirty with 101 records here, is generally not a single transaction. There is a parameter in DSN ZPARM called ACOMAC, which says how many commits in a single transaction. No, how many commits in a single record. And I saw an ACOMAC value in a customer the other day of 1,000. Which is lumping an awful lot of stuff together, quite frankly, but actually it cuts down the number of SMF records by a similar amount. Typically, I see a COMAC either 1 or 5, or, and I think this is the default, 10. So a 101 record is, again, not necessarily a single transaction and almost certainly not a whole conversation. Okay, now, we probably all know this, but as with many transaction types, not all, Workload Manager can actually work with period aging to do multi-period service class management. So if a transaction accumulates enough service, it'll fall into second and subsequent periods. And here, generally, when we're talking about service, we're talking about CPU time. I quite often see people making a mistake on this and thinking that, and I don't really understand how anybody can make this mistake, frankly, but anyway, there seem to be enough people around there who do, who think that it's about elapsed time. If the elapsed time gets long enough, we fall into second period. Well, no, that's not it at all. It's really service, which is most of the time CPU. Okay, just very briefly, you can report in RMF multi-period service classes. In this particular case, the transaction rate in DDF high is almost entirely actually ending in period 1 and a tiny bit in period 2 and almost nothing in period 3. And you can do it at the individual service class level. So here there's 2 service classes, DDF high and DDF large. Occasionally, by the way, I see DDF without multiple periods. I really think we want multiple periods for DDF, particularly if we're worried about what I call feral DDF. Okay. The next thing to talk about, though, is the relationship between DDF work and the Dist address space in DB2. So the Dist address space in DB2 runs in one service class, and generally speaking, the transactions are in their own, well, always they're in their own service classes for almost all the work that happens on behalf of a transaction. So once we get classified, we join an enclave, and that enclave has its own service class. And in this particularly naughty example, we've got transaction A and transaction C ending up in DDF high and transaction B ending up in DDF low. So it's not generally the case that one DB2 subsystem services a single DDF service class. It can do, but generally it doesn't. Okay, now if we look at type 30 view, we can see the and I said this, I think it was last week, we can see the CPU time by the DBM1 and Dist address spaces, and obviously all the others, in various categories. Now, in particular, the Dist address space, you know, almost all the work runs in an independent enclave. And, you know, here we got 68.4% of an engine averaged over the shift. Well, almost all of that ran in an independent enclave and very little actually not on an independent enclave. So you can see that behavior in the type 30. And you can see the zip work in the type 30 as well. And how much of that is an independent enclave? Well, basically almost all of the zip eligible work for DDF work in the Dist address space will be in the independent enclave category. Not quite sure, by the way, why we've got 0.05% discrepancy here. It's probably a more reporting thing than a reality. Okay, now here's a nice surprise. Well, it was a nice surprise to me. The SMF30 contains a lot of useful information for DDF. And I think I mentioned this a couple of days ago, but it bears repeating here. So there are a number of fields for enclave or enclave, however you want to pronounce it, work in the SMF30, and I'm focusing here on the Dist address space for DB2. It will firstly give you a count of all the enclave transactions, which you can obviously turn into a rate. It will give you the CPU on the enclave for all those transactions, which again, you can turn into a transaction rate, right? Compare and contrast this with kicks, where the 30 will not tell you anything about transactions at all. You have to be a bit careful though, because as I say, you can have multiple service classes serviced by the one DB2 subsystem, but the 30 for the Dist address space doesn't know anything about those service classes. So you won't get service class level granularity. You get that from the 72s. And the 30 also doesn't know which period the transactions ended in. So you have to be a bit careful about what you get here. But nonetheless, just think about this. You can, from the 30s, get transaction rate for DDF from each subsystem just by looking at the 30s for the Dist address spaces for those subsystems. And this is exactly what this is right here. You can also get the DDF CPU, and I suppose you could divide the, let's get this right now, Martin, CPU by the transactions to get the CPU per transaction. You also can get elapsed time, and again divide by the transactions to see, do transactions get slower at one time of the day or the other. So here's a real example. So this is a set of 4 DB2 subsystems, Dist address space enclave transaction rates across a bunch of days. Now, I very rarely manage to get multiple days of SMF 101. So this is a really much more scalable way of understanding the DDF traffic. And it looks pretty regular, although, you know, what happened here is not quite clear. Something happened here and something happened here. But apart from that, we have a big peak, a little peak, big peak, little peak, big peak, little peak, and so on. So that is a very nice introduction to the fact that there's significant, I mean, these are transactions per second here. So this is a big amount of DDF work. So one of the things I quite like to do with customers is say, look, you do realize you've got significant DDF work coming into this DB2 or this ZOS system. Perhaps you should pay attention, well, definitely you should pay attention to managing it because it's not a sideshow, it's a significant thing. So this is a very nice effect to generate something like this just from SMF30. And it is, as I say, a very scalable method of doing it. So this is one of the first things I do when getting to work with a customer who's just sent me data. Okay. But we're going to spend most of the time, I think, talking about SMF 101, DB2 accounting trace. So a DDF 101 record would give you basically everything you expect from a normal 101 record. Well, it is one, but you know, like a KICS 101 record or a batch 101 record, IMS or whatever. Right. So it will give you buckets of times. It will give you SQL counts, so connect, you know, commits, deletes, inserts, fetches, opens, closes, that sort of thing. Store procedure calls, indeed. But in addition, it gives you a lot more than other work types 101 records do. And really, there are 2 sections which are worth knowing about. It's actually worth going to the manual and reading up what's in them and then playing with the data. Actually, I was explaining to somebody from IBM China yesterday that you can go to the SMF30 manual and it won't do you a lot of good. You actually need to go play with the data, particularly something like the usage data section where the implications of what's in it aren't clear from the manual. Same is true of the 101 manual and actually the macros that you use to map it, which I hope to give away a bit of a surprise that some of you will get familiar with in the near future. So really there's two sections here, as I say. There's the QMDA section, which is full of names, lovely. And the QLAC section, which is full of counters, again, lovely. But before we get to that, there is a very nice field in a section that exists in non-DDF connection types called the QUAC. Now that field is QWAC-WLME, which is the service class that the 101 record relates to. So if you have a way of managing 101s, you probably could summarize by WLM service class. You can't do that for kicks or anything else, not from the 101s. And I had a conversation with Hugh Smith, who I regard as one of the two Mr. DDFs, where we actually sat down and looked at the DB2 code in Silicon Valley Lab a couple of years ago, and we came to the conclusion it would be almost impossible to replicate this field for non-DDF, which is a bit of a shame, but there you go. For DDF, we have it. If you are a DDF requester on ZOS, so a DB2 calling out to somewhere else, we'll cut a record if you ask us to. Likewise, if it's a piece of work coming from outside into DB2, we will cut a record. And you can tell the difference basically because of the number of conversations sent and received, or the number of SQL statements sent and received, rows sent and received. It's pretty clear which is which. So bear in mind, you may get two records for a conversation where you might expect one, and that's fine. And I'll show you a little bit of what to do with them in a moment. As I say, you can roll up the records. You can also actually compress the records with run length encoding and compression. My bias is towards the compress first, then think about rolling up the records, because you might appreciate the granularity in the records when they're not rolled up, but you may have to do it anyway. Okay, so a little bit more detail on the QMDA and QLAC section. So the QMDA one, as I say, it's got names in it. Now, the structure of the QMDA is significantly different for ZOS as a requester versus other platforms as requesters. But actually, the macro mapping DSN QMDA is quite good at explaining that. Things I'm pulling out in particular that are useful are things like application name. Actually, what's missing from here is TCP/IP address of the requester, accounting information. That can all be jolly useful stuff, as well as the end user ID and some correlation and plan information. If nothing else, these identifiers are quite useful for thinking about what your WLM classification rules should be for DDF, because the identifiers map almost one-for-one onto things you can classify in WLM for DDF with. At the bottom half of the slide, we have counters, which are really common across all platforms. So I gave you some of them. So, bytes, rows, and blocks sent and received, SQL statements sent and received, commits and aborts sent and received. So there's a nice set of counters here, which can be really, really handy. So those are two great sections to work with. I should say that actually, in the standard header of the record, there's a load of other stuff which is useful for DDF, but it's actually frankly useful for things like kicks and IMS and batch as well. But it's an additional set of identifiers that you might find useful. And one in particular, this logical unit of work ID, if you take away the commit count, is something that allows you to tie a whole conversation together. So you could have a bunch of records, the same conversation between a client and a DB2 server. They will have the same logical unit work ID if you throw away the last 2 bytes of it. So that's quite a nice way of tying stuff together. And as I say, QUAC WLME is unique to DDF is really handy as well. So a little bit of a tangent. You think of batch and DDF as strange bedfellows, really, that they're quite different things. Well, the first thing to note is we talk about SAP batch if we're talking to an SAP customer, and I have been recently. That's not the same as JES batch. Really, a batch job in SAP terms is a bunch of transactions in SMF 101 records. which actually is quite nice because it gives you better time-based granularity than Ddf batch would. Ddf batch, a batch job step, would give you a 101 record at the end of the step. It wouldn't give you any commentary running through it, particularly if it was a long-running one. It wouldn't give you any flavor of that at all. Now, I think one of the key things here, though, is bulk work, call it batch if you like, of this flavor can present a problem. So if you have something with an awful lot of commits to it, you may never get out of first period, no matter how heavy the thing is overall. You might stay in period 1 as you start and stop the transactions, in other words, commit scopes within the batch job, even after hours of working. So I think that's a bit of a problem, really. So there's a couple of approaches you could use here. You could use resource groups, I suppose, to control overall access to CPU. You could separate out the bulk or batch work into its own service class and give it a less lofty goal. The issue there is, how do you recognize the batch stuff? Or you could combine these, and maybe you have to use some of DB2's own capabilities, like what I believe is called DDF profiles. But it's a bit problematic if you have something that's a big piece of work, but it commits frequently coming in through DDF because it looks like a bunch of small transactions. And I see that quite a lot. Conversely, some Ddf batch actually uses DDF. The customer I'm working with right now has a lot of outbound DDF work originating from ZOS batch jobs. You get records for this. Now, if it actually connects to another DB2 system, and some of the work I'm looking at right now is doing exactly that, if you have a counting trace turned on in both systems, you get both ends of the conversation, which is kind of nice. I'm going to come back to that one. So this is, I won't spend any time on this, but basically I'm showing you can tie up the client and server records for a ZOS DB2 calling a ZOS DB2. I think that's quite a nice thing to do. It gives you a full understanding of the conversation. And it can be really quite granular. Now, if I come back to SAP a second, I actually just wrote a blog post about this, to be honest. So firstly, if you see a client coming in from an SAP application server, the IP address is going to be in there, and that's how you actually identify the application server. You'll get a correlation ID that's 9 characters long. And what I've seen is basically you can do some useful work with this. Generally, the application name is the subsystem name. So that's probably not terribly helpful to you to know that bit. Or the data sharing group name, actually, in a recent customer I've been dealing with, is the first 3 characters. But then you see DLG for dialogue transactions and BTC for batch transactions. So in the recent engagement, we basically looked at dialogue work versus batch work to look at it driving the transaction rate by time of day, to look at it driving logging by time of day, and various other things. So that's quite a nice thing you can do if you've got SAP on your hands, is to separate dialogue work from batch work. And the final 3 characters of the 9 basically look like a reused process ID. Which gives you a bit of tourist information, but that's about all it does. One key thing which gives you better granularity in terms of reporting here is SAP thankfully fills in the application ID field very nicely. So you can use that to analyze individual application components known to SAP people. So when I mentioned RS process to this customer and RS batch execute prots, which I guess is process, pardon my German, they were able to say, I know what those are, even if they happen to be quite generic. And in fact, in their case, they had SAP BW and SAP R3, and these application IDs were known but different for each of the 2 application types. I mentioned logging just now because one of the things I notice is SAP does an awful lot of log writing in practice. And the numbers in the counting trace, when I see them, document this very clearly and the implications of that. So there's quite a lot of useful work if you happen to have SAP, you can do, which you might or might not be able to do with other kinds of production DDF. Okay, so let's get in some real customer cases now. So just warm up with some basic statistics. So what I've done, and I usually work at this level, is I've summarized by subsystem at the 1 minute level. Now, I'm going to emphasize 1 minute because that's much better, as we will see, than, let's say, the type 30 interval, typically 30 minutes, or the RMF interval, maybe 10 minutes. Not sure that customer's actually on this call, but anyway, or 15 minutes. You know, so at the 1 minute level, you can see something fairly clear. Well, the first thing you can see is that DA1 subsystem on sys-A does most of the DDF work. It's also perhaps the most variable. And I think if you look at it, you can see a very nice pattern. And this pattern is repeated over a 15-minute interval. I very often see this. You would not see this from RMF. You would not see this from type 30. Okay, that was transaction rates from the 101s. From the 101s, you can summarize again at the 1 minute level and see the CPU is a bit chaotic for our main subsystem, but actually you've got these spikes of CPU, you know, from, for example, SysD DSB has one that's basically 3 engines worth for a minute. And SysB DA3 again has got spikes. So this is very nice to see this sort, well, not nice to see the behavior, but it's very nice to be able to detect the behavior and go, what are these spikes? Can we manage them? Okay, this is a nicer one. I think this is very pretty. So the previous 2 slides were at the subsystem level, but equally at the 1 minute level, you can go down at to the correlation ID. And the names in the bottom are the real names, and they're quite commonly seen. So data flow engine, I don't really quite know what data flow engine is. I think that's a customer special one, because I don't often, well, I think I've seen it once. Data flow engine seems to be, in commit terms, peaking. I think it may be every 2 minutes, maybe every 3 minutes, maybe every 5. I don't know. Nice regular pattern, and then suddenly its rate drops. Meanwhile, on a different cadence, you have DB2JCC apply, which is short for DB2JCC application, which is JDBC work. And so there's a JDBC application or several that is pinging, I think that might be, I don't know what it is, let's say 10 minutes, a different cadence altogether. Actually, there's a background always got JDBC, and then we have these spikes. So probably we've got an application that's got a regular spike and everything else that runs in the background. So this is at the 1 minute level. Very nice to see this sort of pattern. Okay, and in this case, you know, it's JDBC that happens to be the main CPU consumer down at the 1 minute level. Okay, so that's basic statistics. I think anybody would want that if they could have it. Okay, so here's another customer situation. Actually, I have not disguised the subsystem IDs here, so if you know them, you know them. I don't think they mind because I presented to them. They seem to enjoy this. Okay, so here we are where the class 1, meaning the total TCB time, CPU time, spiked over a short period of time in both of these 2 DB2 subsystems, which unsurprisingly are in data sharing mode. But there's a bias most of the time towards the blue subsystem as opposed to the red one. But when we spike, there seems to be more in the red one than the blue one. Not sure there's much in that, but there's a systematic bias here between one of them and the other one. And it could just possibly be, and I don't remember if this is the case, the effective engine speed of the 2 is slightly different. That would not surprise me. That might well explain this consistent bias here, apparent bias. So, you know, likewise, class 1 zip, same granularity, same behavior. Okay. If you look at it from the commit rate perspective, that spike in CPU, or those spikes across the 2 in CPU, are driven very much by an increase in commit rate. So if you then drill down, you go, well, what's really increased? Well, it happens to be a JDBC application. This is only looking at one of the two subsystems now, because the other one's equivalent, really. Yeah, it's a spike in the JDBC application in terms of commit rates. And that can happen for all sorts of reasons. It could be a so-called batch job coming in through JDBC. In this particular case, actually, it was a test that they were running. These are not production DB2 subsystems. Okay, the other thing that happened is the response time profile changed. So what I've done here is I've thrown response times into buckets and made them add up to 100%. And the perceptive amongst you will notice I start at 1 second and then I double and then I double again and so on to get the buckets above 1 second. And I halve and halve and halve again to get the buckets below 1 second. But what you should notice is the shortest transactions, which normally predominate, become a lower proportion of the total when we're doing this test. So it's longer running transactions that suddenly come in. That's quite a nice thing to do. And you can do it, as I say, at the 1 minute level is probably the best level to do it at. So was it that we had fewer fewer short transactions? No, it's actually we had more transactions in the longer values. So the yellow here, which is between 1/4 of a second and 1/8 of a second, that predominated in a way it didn't before, for example. So that's quite nice. And if you zoom in, you don't have to zoom in, but you can, and you could fill in the gaps, by the way, if you wanted to do it at lower granularity than 1 minute. In fact, it's worth mentioning at this point, you could go with 101 records down to 1/100th of a second granularity. I would advise you not to, because you can get a whole bunch of yeses and nos, because it'll get very lumpy down at 1/100th of a second, but you could do it. In my code, frankly, the enablement to do that is there, though I've never actually done it for reasons which should be fairly obvious. Okay. I took the same test and I broke it out using that quack WLME field. And here, the test for DDF work, alarmingly to me, is just a name, folks, so let's relax about it, is in STC medium. I do not know why DDF work is running in a service class 14 medium, but there it is, right? It's from the 101s telling you that, not from RMF, which would have had, as I say, the 15-minute granularity probably. Okay, so that's 2 customers down. Now, I haven't chased Stephen away, so he likes this term, I know. Sloshing or not. This is what happens if you're insane enough to go down to the 1 second level across a set of data. And in this particular case, it's 30 minutes. So that's 1,800 data points, right? You could drill in and go, this set of 4 subsystems, are we having sloshing where work rushes to one subsystem and then to another and so on, as those subsystems look like increasingly good and less good places to run work? When I look at this, I mean, you can decide for yourselves, but I don't think this is sloshing. I think this is more or less averaging out, or even not averaging out, looking like relatively reasonable behavior. It looks like we've just got balance between these, and there's no particular rushing to one place and rushing to somewhere else, really. You just get some minor 1 second level variations, I would have said in this. But you can make your own mind up from, if you drill into the 1 second level, or maybe below, but probably not, you can see whether we're getting, as I say, a sloshing phenomenon. And there's a slide here which describes the phenomenon in a bit more detail. What I think matters about sloshing, though, is what is the net effect, not what is the behavior. Because I think while we might think we want balance between cloned members running DDF work, what really matters more to us, I think, is what's the performance impact. So I would say that if the utilization is at 90% or above, we care much more about sloshing than we do if it's down at 50%, unless we're seeing some elapsed time issue related to it. So it depends where you are as to whether you really need even smooth balance, or whether you would allow a a certain amount of variation that over a longer term evens itself out. Now, this is really a byproduct of server WLM, which is really about placement recommendations and health and decisions. Round robin as a method probably would not induce, I don't see how it really could induce, wild oscillations and sloshing. I will say you probably wouldn't see this sort of evidence or counter evidence in RMF or SMF30 because they're simply smoothing out over much too long a time range. But we, as I say, you can go down to a ridiculous level of 100th of a second granularity, but probably 1 second granularity is enough to satisfy, obviously over a short period of time, like 30 minutes in your analysis. So that's sloshing. While we're there, the response time distribution looks quite nice here. You know, if you were setting a goal and you wanted to just about achieve it, you might say, and normally nowadays, by the way, I plot this cumulatively as well as bucket by bucket. You might say something like, 90%, 95% in half a second. Maybe it should be tighter than that. But the point is, you can get from the 101s the response time distribution with any level of granularity you please to be able to think about setting goal. Now, sometimes it's not as simple a shape as this. In fact, we've got a little bucket here, which is is very short transactions, as well as the main crop, which is round about 1/10 of a second. Quite often, to be fair, I'm seeing everything in a less than a millisecond bucket, which becomes very difficult with WLM to control anyway. But at least if you do the analysis using the 101s. Okay, so I'm getting a little short on time, I think. So let's look at one of those customers again. This is a completely different perspective on it. You can get the names in the frames and start looking at who it is who is connecting. And some of that might be about enforcement or security, perhaps, but some of it might be about nosiness. But knowing what's connecting to DB2, I think in lots of ways is kind of important. So the very simple case is the case of a client that connects directly to DB2. And this is just an example. You can see these production web servers, 3 of them here, direct connect, no gateway. In fact, basically the IP address of them is the same as the gateway IP address. That's how you know it's a direct connection. Then you could do things like, well, here's a server, whatever the IP address is, and obviously I've obfuscated it, although in one of those blobs, there's a big fat clue to the real IP address if you know how to look at it. But here, same serve client, 2 different JDBC levels, JCC 210 and JCC 340. You might ask questions like, why have we got a 210 client still when we'd rather be up at 340 or maybe beyond now throughout? So that's a nice piece of extra tourist information you could glean. Okay. Sometimes it's useful to actually group the IP addresses in ranges, and I'm going to use a term here called batteries. So batteries of clients, often middle tier servers. We'll come back to that one in a minute, actually. And just for completeness, I wanted to throw in the fact that and I color coded these, and this, by the way, is the same tool I was talking about a couple of days ago. iThoughts is what I use to do this mapping, or to do the diagramming rather. So, you've got here Linux on x86 64-bit client. This string came out of the record. This string also came out of the record. You've got a DB2 11 client with its own IP address. You've got more DB2s, but this time version 10 DB2s connecting with its own IP address. And so on. This is the same color. And here we have SQL running on Solaris. The character string Solaris actually appears in the record. And here's AIX 64-bit. So my point here is you can see multiple platforms, including SQL Server or whatever it might be, as the middle tier. Kind of nice to see what kind of connectors we've got. Okay, now the term battery I used just now. So this is a case where the customer had two batteries of application server middle tier machines with their own IP addresses showing up with contiguous ranges. Two sets of 16, excuse me. So the first thing you notice, I think, is that within each battery, we don't have evenness in terms of request rate. We have some machines that are busier in terms of sending requests to our DB2 than others. The other thing you will notice, I hope, is that actually one battery, W2M, is busier in terms of sending requests into DB2 than the other battery, W3M. You might like to ask why that is. You might or might not care. But it's the sort of thing you can find from a counting trace if you look at it in the right way. Okay. Now, this is something new as of last year. So I think I presented this once so far. I mentioned before you'd like to see 60% zip eligibility for DDF work. And if you don't get it, you probably want to know why. Now, if you go down to the package level, turning on accounting trace classes, probably 7 and 8 are sufficient for this one. Yes, they are definitely sufficient for this one. You can get package level GCP CPU and zip CPU, and you get to know what kind of package it is. The technical piece here is if you are a non-native stored procedure called from a DDF client, you're not going to get the zip eligibility. However, if you are a native stored procedure called by a DDF client, you will get the 60% or something like it. So the point here is, this first blob here is a stored procedure that's not native. And you're not getting much zip eligibility at all. The next one is a native stored procedure. And here, the orangey red is zip. The blue is non-zip. So you're getting, roughly speaking, the right amount of zip offload for a native stored procedure. Here's another one that isn't a stored procedure at all. And again, you're getting the right zip eligibility. Here's a stored procedure that's not native. You're getting not much. Likewise, this one. And here's another native stored procedure. And I won't carry on, but you can see a couple more native stored procedures over towards the right. My point here is, if you look at package level, you can understand why you're not getting why you're not getting the 60%, or at least one of the reasons why you're not getting the 60%. So you probably would go to the owner of the first stored procedure and say, is it feasible, and maybe it isn't, probably it isn't actually, to rewrite this as a native stored procedure so we can get the zip eligibility. So I think that's quite a nice result from IFKID 239 package level accounting trace. Okay, now here's a fun one. I'm not sure I remember which customer this was. So basically, this is going down to, I think, the 1 second level. I've got a machine that thinks I'm talking to it. Going down to the 1 second level across a number of subsystems, different color coded, and maybe we have sloshing here because maybe we're favoring one subsystem over another at various times. So that's a nice behavior. But what we're really seeing that's most interesting of all is suddenly we stop getting records with timestamps in this time frame. And then we have a huge amount of catch up to do when we restart. And this is something like a minute's worth of what I would call a hiatus here. Now, so I think this is kind of nice. And then we get some pinging at regular intervals after that. So this is quite a nice piece of detailed behavior around a not very nice incident. Now, one of the things I would say is in the record, we get the end timestamp. We also do get encoded a different way, the start timestamp. So you could play this game one of two ways, and you probably should do both if you're investigating this way. You could say, did the transactions fail to end in the hiatus? Is that what we're seeing? In other words, they got stuck in DB2. or did they not even start in this time period, in which case they got stuck probably outboard of DB2, and that might be diagnostic as to what the problem is. So I think this is a nice technique if you have the one-on-ones around the incident of enough volume that you can go down to the 1 second level to actually try and diagnose this. And yes, of course, you could go down to 100th of a second, as I say. I'm not sure I would, frankly. I think this is enough. Start times, you know, arrivals not happening versus departures not happening, that could be enough to give you some useful information. And this actually happened to a couple of customers of me not all that long ago, within weeks of each other, that this technique came in really handy. And then one of them, and I can't remember which one it was the transactions didn't arrive. And the other one, it was a case of they didn't finish. So that's quite nice. Okay, so what is it we've actually learned, if anything? Maybe you've learned some things like this. DDF is important to manage. And I probably should say it's important to know if you have DDF work coming in. And the SMF30 technique is a really nice way of working out, yes, we do have significant DDF work coming in, even if the DB2 folks didn't tell us that. And many of the people on this call aren't DB2 folks, so you're probably in the category of if only they told me, well, I can tell them. Always nice position to do that. DDF management needs to happen with WLM and by application level examination and tuning. The key instrumentation, once you've been sensitized by the type 30s to the presence of DDF work, is a counting trace, SMF 101. And as I say, you can do it down to arbitrarily short time intervals. And hopefully, so far, you've found this to be enough fun with DDF that you could have, that you might actually want to do it yourselves. So here's the good news. At least I think it is good news. I'm really pleased to be able to share this with you. Last week, I got through a fairly short process in IBM that gave me permission to open source my SMF 101 DDF code in its entirety. The repository for that is on GitHub, and this is a live link to it. The license is MIT, and I've done quite a few open source to license as, let me license as MIT. That means you can fork the stuff, you can build your own, you can collaborate and contribute to this. So I really personally am welcoming contributions to this project if you want to do it. Hopefully the license being MIT is acceptable, and the openness factor of this is acceptable for customers to use this and other vendors and consultants and whoever. My experience with open source projects is you never know who's going to walk in and contribute, if anybody, or use it, and that's fine. So hopefully it's stuff you can use, and if you like it, you can contribute. So far, and this is actually last weekend's work, I published in that repository the database build job and a sample report job. Now, what you need to do to install this, apart from getting the pieces, is you need to assemble a DF-sort E15 exit. You need to do this on a system where you have the DB2 macro library, SDSN max. To actually use it right now, I'm afraid it's a case of get out and get under with ISPF edit and make some global changes. But I've documented what the variables that need changing are in that. So hopefully that's not too difficult. Our heritage is actually doing this with ISPF file tailoring, but frankly, shipping an application to do that is really not worth the candle. What is worth doing, and I'm working on this right now, is creating zero SMF workflows to do the tailoring for you, which you may or may not like, but you know, the way of the world is zero SMF. So that's going to be kind of fun. Personally, I'm very happy to talk through with anybody who wants to know the installation, the tailoring and use, and maybe some interpretation. Really in the spirit of getting people going with this. My aim is to publish a load more sample reports, because today's sample report merely lists what subsystems you have on what systems, and commit rates and CPU and transaction rate and record counts and stuff like that. And similarly down at the correlation ID level. That's only I mean, I'm not showing you this in this presentation. Almost everything I've done in this presentation in graphing terms is done with this code, right? So I'd like to push some more reporting into the field.
Sorry, I'm having trouble hearing you.
I hope you all aren't having trouble hearing me, unlike SIRI next to me. Yeah, I would like very much collaborators to push their own reports and actually push the envelope in general of what we're doing here. I'll rely on the GitHub issues mechanism, for complaints, suggestions. I would like to change this, whatever. But feel free to get hold of me however you want to. I've recently tested it with both DB2 version 11 and version 12. And the DB2 macro library at both levels. There are definite issues before version 10, and that's because some of the key fields we really need were 4-byte, and now with version 10 and later they're 8-byte fields. So we're not going to support version 9, I'm afraid. In fact, actually, originally this did support version 9, but I made it support version 10 because it's a much better place to work from. In the documentation, it says DF sort, but, and I've not tested this, if you have sync sort, it almost certainly will work just the same way, right? So I've tried to be generic in the documentation with the term. What you need in data terms is DB2 accounting trace with the classes 1, 2, and 3 turned on, which is plan level. There is additional value, as I've shown you with this zip eligibility example, at the package level. You have to turn on trace classes 7, 8, and 10 to get that to happen. Now, you might do this in a narrow time range for a particular subsystem. You might do it all the time. I don't know what you feel able to do. My genuine hope is, because I use this stuff and find a hell of a lot of value out of it, that other people will do. If there are licensing issues, I'd like to understand them, or other inhibitors to, let's say, customers using them. It's all open source. You can see the assembler exit. You can see everything in it. So there's nothing sort of secret or actually proprietary in that. So that's one of the things I wanted to share with you, because I think that there's a bunch of you on the call who will actually enjoy working with this and may even contribute to the project. They obviously don't have to. So that's all I've got. Somehow I seem to be, I think, just within time, aren't I? I don't see any questions in the chat or comments, but does anybody have anything they'd like to ask or share or comment? Meet me in the pub. Yes, that's a lofty hope, isn't it? Nominate your pub. Yes, my pub down the road opened for a couple of days and then had to shut again, unfortunately, which is the way of at least this part of the world. Okay, well, you can always get hold of me. I'm sure all of you know how to. Yes, quite right. It's just a small body of water. So please feel free to at any time. And thank you very much for your time.
Thank you very much, Martin. Really appreciate the presentation. Thank you all who attended as well. Just as a reminder, I've also put a direct link to leave some session feedback. It will really be helpful for us, especially for next year as well, going forwards, to help form the sessions. And I've also put a link in to our charities giving page for NHS Charities Together. We're almost halfway to achieving our goal, and any amount, big or small, will be very helpful, especially if you've been enjoying this wonderful free conference over the past 2 weeks. We'd really appreciate that. And yeah, I hope you all have an enjoyable rest of your day.